Algebra 2, Chapter 10.3, exercises 13 through 20. In this section, we're solving rational equations, and this problem 13 is the next part of this set that started with number 9, solve each rational equation algebraically. And so for a couple of these problems, I'm also going to confirm graphically using a calculator. But we're going to use the techniques that we've developed earlier in our last video lesson, which are to find excluded values, and then also to find the least common denominator by which we can multiply. And our strategy in these problems is going to be to clear the denominator. And when we clear the denominator, we're going to end up with a usually either a linear or a quadratic equation that we can solve and find our solutions. So to the right here, we're going to take each of our denominators that has a variable in it. The first one we have is 2x plus 6. We know that that denominator cannot be equal to 0. And so if we factor out a 2 from 2x plus 6, it's going to be 2 times quantity x plus 3. And therefore x plus 3 cannot equal 0. And what happens is we can get rid of the 2. It's like dividing both sides of the equation by 2. And so therefore x cannot equal a negative 3. Now again, the book and a lot of books will use the excluded value x equals. I like to put x does not equal because that is an accurate description of what x cannot be. And then on the right side, we also have the second denominator, x plus 4, cannot equal 0. So x, therefore, cannot equal negative 4. So these will be our excluded values. X cannot equal negative 3, nor can x equal negative 4. Now, the next thing I'm going to do is look for the least common denominator. So I'll put LCD determination. Okay, so that's going to be, already we have 2 times quantity x plus 3. We also have 6, and we also have on the right one x plus 4. Well, the 6 will include that 2, so what we're going to end up having, our LCD, our least common denominator, is going to be 6 times quantity x plus 3 times quantity x plus 4. And that's what we're going to be working with here. So we're going to rewrite this rational equation here. So we put 5 over, I'm going to write 2 times quantity x plus 3, and we're multiplying this by 6 times quantity x plus 3 times quantity x plus 4. And then we have minus 1/6. And we're going to have times 6 times quantity x plus 3 times quantity x plus 4. And that's going to be equal to, we have 2 over x plus 4, and we multiply that by 6 times quantity x plus 3 times quantity x plus 4. And now we'll be able to start canceling things. On the left one, this x plus 3 in the numerator cancels the x plus 3 in the denominator. We have this 6 over 2 cancels to become 3 in the numerator. And then our next fraction here, we have 6 over 6. And the one on the right side of the equation, we have x plus 4 over x plus 4. So, just simplifying out here, we have 15 times, because 5 times 3 is 15, times quantity x plus 4. And then we have this minus, we have x squared, because we have 6 over 6 canceled, so we have, and I'm just multiplying these together, quantity x plus 3 times quantity x plus 4. So you have x squared minus 7x, because 3x plus 4x, and finally minus 12. And that's going to be equal to 2 times 6, which is 12. We're going to have times quantity x plus 3. And then going ahead and distributing, we have 15x plus 60 minus x squared minus 7x minus 12 equals, on the right side we have 12x plus 36. Okay, now we have some, we can do some combining of like terms here on the left. We have, I'm going to put negative x squared, and then we have 15x minus 7x. That's going to be plus 8x. And then for the numbers, we're going to have 60 minus 12, which is going to be plus 48. And then that's going to be equal to, on the right side, 12x plus 36. Now what I'm going to do is get rid of everything on the left side. And the reason I'm going to do that is because I'm going to want to have this x squared become positive. So I'm going to add x squared, subtract 8x, and subtract 48. And do likewise on the right side. So we're going to have plus, up on the right side, plus x squared. And we'll have minus 8x and minus 48. So everything cancels on the left side. So we have 0 is equal to, what we have left is we have x squared and 12x minus 8x is going to be plus 4x. And then 36 minus 48 is going to be minus 12. So now we have a quadratic equation, and if we can factor this, that's going to make our life a lot easier. So the factors of x squared are x and x. We have minus 12, so we're going to have a negative times a positive. So what two numbers, when multiplied together, equal negative 12, but when added together equal 4? I'm thinking 6 and 2 are involved here. So it's going to be here x plus 6 and x minus 2. So we have x minus 2 is equal to 0. So x is equal to 2. And x plus 6 is equal to 0. So we have x is equal to negative 6. And what we are using here is called the zero factor property. because anything multiplied by 0 is 0. So these are the solutions. These are real solutions because they are not extraneous. They are not part of our excluded values. So these would constitute our solutions. Okay, let's go on to problem 15, which really starts out our word problems. Word problems are can be pretty difficult for a couple reasons. One is that a lot of times I find that they're not very intuitive. They're hard to set up, and sometimes the numbers get kind of big, and that also is a degree of difficulty. Well, I forgot to show you here on number 13. I actually graphed this equation for number 13. I put them both there, and we have a 0 at -6, and we can tighten let's tighten the window on this too. We'll go from -1, y minimum -1, y maximum 1. So we have a solution at x equals -6 and at x equals 2. Yes, that's right there. Okay. Okay, here we have number 15. A save percentage in lacrosse is found by dividing the number of saves by the number of shots faced. A lacrosse goalie saved 9 of 12 shots. How many additional consecutive saves must the goalie make to raise his save percentage to .850? I find fault with this problem, the language. The save percentage in lacrosse is found by dividing the number of saves by the number of shots faced. And what else do you have to do? Multiplied by 100. To get percentage, okay? And then ask lacrosse goalie, how many additional consecutive saves must goalie make to raise his save percentage to .85? Well, how about 85%? Save percentage to 85%. That's what it should say, because 0.85 is not a percentage number. So just some criticism with the wording of the problem. But what we're going to have is 9 plus the s over 12 plus s, and that's going to be equal to 0.85. And so we are setting up here. It says do not solve. We're not going to solve this. I will tell you that if we did solve this, we would get 4.33 extra shots. I don't like using s as variables, and the main reason I don't is because they look kind of like 5s. So that's looks more like, anyway, that's going to be problem number 15. Okay, next on number problem 17. A new ice skating rink will be approximately rectangular in shape and will have an area of 18,000 square feet. Using the equation for the perimeter P of the skating rink in terms of width W, what are the dimensions of the skating rink if the perimeter is 580 feet? Well, the area is going to be length times width is going to be 18,000. So that's one of our equations. And then we have a perimeter. Perimeter is going to be equal to 2L plus 2W. And then working this in for the actual numbers we're given, if perimeter is 580 feet, it's going to be equal to 2 and L. We're going to leave this in terms of W. So L we can get by taking 18,000 dividing by W. So we have 2 times 18,000 divided by W. And then we have plus 2W. And so what do we have here? We have a rational equation we can solve. And what we're going to do is multiply this whole equation by W to clear the denominator. So we multiply by W, we get on the left side 580 W is equal to 2 times 18,000. Well, that's going to be 36,000. And we divided out W, so W, that's going to cancel. So we're going to have 36,000. And on the last one we're going to have is we're going to have plus 2W squared. So now we have a quadratic equation that we should be able to solve. And let's go ahead and subtract 580W. So we have 0 is equal to 2W squared minus 580W plus 36,000. Now what do you notice here? There's a common factor of 2, so we can say 0 is equal to 2 times W squared minus 290W plus 18,000. So therefore, 0 is equal to, we're dividing out the 2, W squared minus 290W plus 18,000. Now, what two numbers, when multiplied together, equal 18,000, but when added together, equal 290? So we have W, W, and they're both going to be minus. Well, how about 200 times 90? Let's go to that calculator. 200 times 90. Yeah, 18,000. That checks out. So 290. So W equals 200 and W equals 90. So those are the dimensions. So the dimensions, and they're going to be in the units of feet. These will be our dimensions of the rink. 200 feet by 90 feet. Okay, let's go to this last one we're doing this set. A riverboat travels an average of 14 kilometers per hour in still water. Riverboat travels 110 kilometers east up the Ohio River and 110 kilometers west down the same river in a total of 17.5 hours. To the nearest tenth of a kilometer per hour, what was the speed of the current of the river? Well, what we're going to do is to go upstream. Our speed is going to be 110, and we're going against the current, so we're going to have 14 minus c, and downstream we're going to have 110 over 14 plus c. So our rational equation we're going to get is we're going to have our upstream 110 over 14 minus c plus 110 over 14 plus c is going to be equal to 17.5 hours. And our common denominator, I'm going to work this to the right, it'll be our LCD, but I'll just put common denominator, is going to be this 14 minus c times quantity 14 plus c. So let's go ahead and work this out. So we have 110 over 14 minus c, and we're going to multiply that by 14 minus c times 14 plus c plus 110 over 14 plus c times 14 minus c times 14 plus c, and that's going to be equal to 17.5 times 14 minus c times 14 plus c. And then we're going to have cancellations here. 14 minus c over 14 minus c. Then we have 14 plus c over 14 plus c. And we work it all out. We're going to get 110. I'm just going to write here 110 times 14 plus c plus 110 times 14 minus c and it's going to be equal to, we're going to have 17.5 times 14 squared. All right, 14 is 14. And we're going to have minus 14c plus 14c. They're going to cancel each other out. And so we're going to end up with having minus c squared. So we're just going to be solving this quadratic equation. So we have The numbers are pretty big here, so let's just work this. We have okay, that's going to be 1540. We're going to have 17.5 times 14 squared, 3430. That might be all we need here. So just remembering those here. 1540. So we have 1540 plus 110C plus 1540 times plus 110C is going to be equal to 3430, I think it was. Yeah. And we're going to have minus 17.5 C squared. We are also going to have here (110) times negative c. We're going to have minus 110c. So 110c minus 110c will cancel each other. And what we have left on the left side is, let's just subtract 3430 from both sides. So we get negative 17.5 c squared and the other side of the equation we have 1540 times 2 minus 3430. So we have minus 350. And we divide by negative 17.5. And I'm kind of running out of room here below. So I'll work to the right. So we have c squared is equal to 350 minus 17.5. We get, I want 350 divided by 17.5. $20. So we get 20. So we're going to have c is going to be equal to plus or minus square root of 20, which is going to be plus or minus let's go square root of 20. What do we get here? About 4.47. kilometers per hour. Okay, so that's going to be it. Now, one thing I did is I worked this out on I put the equation, the graphing calculator here. I'm going to go ahead and delete that equation. Come down here and So here we have the equation entered, and we have x instead of c, and I'm going to go get a standard window, go to zoom 6, and here's where our solutions are. Negative square root of 20, positive square root of 20, second trace 0, and I'm going to use the one on the right here. Left bound, press enter, go to the right, enter, enter. So we get 4.47. So we have plus or minus 4.47. So what this means in the real world is that the river is flowing at 4.47 kilometers per hour, and the positive solution is the current going with the boat. The negative 4.47 is against the boat. So we're going to say 4.47 kilometers per hour. Okay, which we have right here. Okay, and problem 20 is another one that's could be worked out. So I think these word problems are kind of difficult. Numbers get kind of big and unwieldy, sort of hard to set up, but eventually get the hang of these. There are certain types that, given enough experience, you'll get familiar with and be able to do better on your own. Good luck, and thanks for viewing.